All right, kids, I should be recording. I'm going to go ahead and explain the activity we did today, or handout that we did today, which is investigating the oxidation of metals. So the oxidation of metals are combination reactions. So let me go ahead and change that from synthesis to combination. So we're going to use the common ion sheet to predict the products of oxidation of metals in combination reactions with oxygen. So oxidation is the adding of oxygen to metals, or I should say to elements. That's where the word originally came from. Oxidation meant you're adding oxide, or making an oxide by adding oxygen to a metal. Here is cadmium. And one thing that I want to remind you that the metals on the periodic table are all shiny gray objects by and large. So if you look at osmium, iridium, platinum, silver, cadmium, mercury, if you look at all of these, they're typically shiny gray metals that you're familiar with. You don't usually find many of them in this form. They are usually combined with other elements when you do find them in nature. But for the purposes of this lesson, when I say a metal, you should think of it as a shiny gray thing that has the potential to rust. And here, this first practice problem, or a first example, it says show the oxidation of cadmium metal with oxygen. So cadmium metal, we're going to call that a solid metal. That's what the S stands for. And that's going to have oxygen combining with it in a combination reaction. So this takes the form of A plus X makes AX. I guess I can go ahead and write that above here. A plus X makes AX. So you should think of that as a combination reaction. And I wrote cadmium because that's the abbreviation for cadmium. Oxygen, O2. That's how we find oxygen in nature, is O2 gas. And that's going to make cadmium oxide. How do I know that? Because cadmium and oxygen, when you combine it, is going to make cadmium oxide. So how did I know? How did I come up with this reaction? Well, I just explained this. I know oxygen, O2, is gas, and all metals at room temperature except mercury are solid. Then only comes the question of how did I come up with CDO? The common ion sheet, this thing, has cadmium on here, right there. CD2 positive has cadmium. Excuse me, I got a little throat infection coming. It forms the CD2 positive ion most commonly. And I know oxygen from the periodic table. Oxygen is right here in group 6A. And group 6A usually forms a 1-2 negative charge because it's 2 spaces away from neon, and it gains 2 electrons to do that. So that's a little bit of review. So I know CD, according to the handout, is CD2 positive, and oxygen is O2 negative, according to the periodic table. And those two things are going to directly cancel each other, making CDO. Now, all metal oxides are solids. When you form a metal oxide, it's going to be in solid form, and that's why I wrote the S here for solid. So cadmium oxide is CDO solid. And then we just need to balance the reaction after that. So let me go ahead and walk through that process. So I have CDO, eliminate that. There's one oxygen here in CDO, so I need to put a 2 in front of that to balance it. And then now I have two CDs, two cadmiums. So I'm going to put a 2 in front of the cadmium to balance that. Okay, so that's that example problem. Let's go ahead and do one more example problem. It says show the oxidation of chromium to form chromium 3 oxide. So I'm going to walk through this with you. Okay. So I know I have chromium solid. Think shiny gray metal when it tells you, hey, you're going to oxidize a metal. So it's going to be a shiny gray metal, solid, most likely. And that's going to form chromium 3 oxide. So if we're forming chromium 3 oxide, I know that's going to require oxygen gas to do it. And I know I'm going to have Cr because it says chromium 3 oxide. And I know it's going to have oxygen in it, so I'm going to put an O there. Now, going back to what I had said, oxygen always forms a 2 negative charge. 2 negative. So let's go ahead and write our 2 negative there. And chromium 3, that 3, you might remember from first semester, means chromium has a 3 positive charge on it. 3 positive. So let me go ahead and write 3 positive. There we go. Now comes a question. How does Cr3 positive and O2 negative come together to form an ionic compound? Well, let's go ahead and do that. If I have Cr3 positive and O2 negative, that 2 you can put down at the bottom right of the Cr, and that 3 you can put down at the bottom right of the O. So you could do it like that. They usually call that the crisscross method, where you put a 2 down here at the bottom. There we go for that. And you put the 3 from the chromium down here at the bottom of the oxygen. So you could do it that way. And you get Cr2O3 as your chemical. There's another way you could think about this. So I'm going to go ahead and put the Cr2O3 right here where the product would go. So let me go ahead and replace that. And there we go for that. But I also want to teach you the logic of thinking through what Cr2O3 means. Okay, so I know I made chromium 3 oxide solid. That's my product. But what does this mean? This says I have 2 Crs, each of a 3 positive. Okay, so I have 2 Crs, each of a 3 positive. I'm going to go ahead and make 2 Crs, each of a 3 positive. I'm representing that right there. And this says I have 3 O's, each with a 2 negative. So I have 3 O's, each with a 2 negative. Now, this has a grand total of 6 positive, and this has a grand total of 6 negative. 2 negative, 2 negative, and 2 negative is 6 negative. 3 positive and 3 positive is 6 positive. And these two things come together in the form of Cr2, representing these 2 Crs, and O3, representing these 3 Os, with this much total charge contribution and this much total charge contribution to cancel each other out. So let's go ahead and write that as such. Cr2O3. Now, since I'm making this video as a instructional video, I guess I should go ahead and do some more problems with you. Okay. So this one says show the oxidation of gold. Here's gold 3 oxide. Where are you going to start with this? Go to the periodic table. I know that that's going to be a solid. It says we're making the oxide and oxidizing again. So I'm going to need oxygen gas. And it's going to be combining with it. So I should have a plus sign there. And we're making gold 3 oxide. So I know I'm going to have Au for gold and oxide, which is O. Now, I don't think your ion sheet has gold on it. It should, but it doesn't. Gold always forms a 3 positive charge. But wait a minute, Mr. B, you told me that I got this ion sheet that tells me the charge of these metals, but gold's not on your sheet. And that's why I gave you the charge of gold right there as gold 3. So we have gold that's going to form 3 positive. How do I know that? I gave it to you as the Roman numeral. So you should write that as gold 3 positive. And what's the charge on oxygen again? It's 2 negative. Okay? So now comes the question of how does gold Au3 positive come together with O2 negative? Well, let's go do those problems over here. So I'm going to highlight that. And I'm going to go do that problem over here to the right. All right. How many 2 negatives are going to be needed to cancel a 3 positive? Well, the least common multiple of these is 6. So I know that 2 negative is going to go into 6 3 times. And 3 positive is going to go into 6 2 times. And if I do the problem like that, I know I got a grand total of 6 positive and a grand total of 6 negative, and those cancel out. So if you use the crisscross method, you bring a 3 down here and a 2 down there, and you would get Au2O3. Au2O3. Let me fix my subscript thing there and make the 2 a subscript and the 3 a subscript. And that's our chemical, Au2O3 solid. Uh-oh. Get rid of this. But what about balancing? So now I have 2 gold atoms on my left, on my right, excuse me, and I have 1 on my left. So I need to put a 2 in front of that. And if you look here, I have 3 oxygens on my right and 2 on my left. So again, least common multiple is 6. I'm going to put a 2 there to get 6 oxygens. 3 oxygens times 2 is 6. And what do I put in front of O2 to get 6? You put a 3. Now, when you do that, you have 2 AUs times 2, which is 4. So I'm going to need to increase this 2 to 4. Okay. So I've done all that. And now that I'm thinking about it, let's go back to this last example problem. I had forgot to balance this. So let's balance this last example problem. I have 2 chromiums on the right over here. And I have 1 chromium on the left. So I'm going to put a 2 in front of that to balance it. And if you look at oxygen, I got 3 on the right and 2 on the left. So I'm going to go ahead and put a 2 in front of that and a 3 in front of this to balance those. And when I do that, similar to the last problem, by putting a 2 in front of this, I got 4 chromiums now. And I got 2 chromiums on the left. So I'm going to put a 4 in front of that. So this is bringing together a whole bunch of skills. to solve these problems. Write equations from word statements. Let's go ahead. I'm going to jump forward to this one here and do this last example problem. Show the oxidation of silicon to produce silicon 4 oxide. So I'm going to start with silicon. That's Si, and that's going to be solid. And I'm reacting it with oxygen. So I'm going to go ahead and copy that stuff up here to say, okay, I'm reacting it with some amount of oxygen to produce SiO. Now I haven't figured out the charges and all yet, but I know that I'm going to start with solid silicon, react it with oxygen gas to produce SiO, silicon oxide. What's the charge on oxygen? It's 2 negative. What's the charge on silicon? It's 4 positive, according to this Roman numeral. And a little reminder, where did 2 negative come from for oxygen? Its position in the group number in the periodic table. So I'm going to write 4 positive for this silicon atom there. Now there comes a question. How does silicon with 4 positive come together with oxygen with 2 negative? So that's our big question. So you could use the crisscross method. 4 goes down here at the bottom right. 2 goes over here at the bottom left. You could do that. Let's do it. So 2 down here. 4 down here at the bottom left. The charge goes away. Fi2O4. Now, when you do that, you can simplify the 2 and the 4 to 1 and 2. And not only can you do that, that's generally what we do in chemistry. So you would simplify that to 1 and 2. And we don't show 1s usually, so I'm even going to get rid of that 1. So that's the chemical we'd form, SiO2. And balancing, we have 2 O's here, 2 O's here. So that's balanced. And the Si is already balanced. With Si, there's 1 of them here and 1 of them here. So this is actually good to go. Turns out this is our simplest balancing problem that we've come across. But again, I want to show you the other method to think through. Silicon with a 4 positive coming together with oxygen of 2 negative. You should think, okay, I'm going to need 2 of oxygen 2 negative to cancel a 4 positive silicon. So SiO2. That's how you should think about bringing these ions together to cancel these charges. But with that said, that is the end of that problem. And I'm going to make this the end of the video. Hopefully, you will have no difficulty doing this one, this one, this one, and this one. Maybe I'll make another video walking through those. All right. Thank you.